Hey, for this video, I'm going to go over how to solve a formula for a specific variable. It's a little bit different than just evaluating a formula. So when you're evaluating a formula, you're taking the formula and you're replacing the variables in the formula with numerical values, and then you're working it out, you're simplifying it. But when you take a formula and you solve it, basically you're manipulating the formula so that it equals one of the variables. So for example, if you have like the area formula, we know area equals length times width, but maybe you need to solve it for width. So you would, instead of having area equals, you would want width equals, and you would have to figure out the relationship between the area and the length. So that's what you're doing here. The same steps for solving equations apply to solving formulas, but it can be a little frustrating because when you're solving an equation, you have numbers that simplify, things kind of condense down, right? But when you're solving a formula for a specific variable, things don't simplify quite the way we want them to, okay? So let's get started. Okay. So solving formulas for specific variables. And it is trash day, so you might hear the trash truck. I can hear it coming down the road. So just ignore it if you hear it. My windows are open. Okay. So let's start really easy. Okay, now keep in mind the steps to solving an equation still apply to solving a formula, but again, things don't collapse. They don't simplify down like they do with an equation. So let's start, like I said, with something really easy. Let's say we have P equals R minus C. This is a classic formula for profit. Profit equals revenue minus cost. And what we want to do is we want to solve for C. Okay, what this means, solve for C, it means that we want to get C by itself. So you want a single positive C equaling some relationship between P and R. So what I would do first is I would go ahead and either subtract R or add C. Either one is fine. I'm going to start by subtracting R. So that means I'm going to get P minus R equals negative C. Now, you've got the C alone, but the issue is you always want to solve and make sure that the variable you solve for is by itself and positive. So what I could do is I could divide each term by -1. So I would get negative P, and then that's positive P divided by -1, that makes P negative. And then I've got negative R divided by -1, which makes it positive. And then negative C divided by -1 is positive C. So all I'm going to do at this point is just clean it up a little bit. And I would get that the cost is equal to the revenue minus the profit. And that's it. So all we did was we manipulated this formula. We moved things around legally so that we rearranged it to where instead of having profit equals, we had cost equals. Let's try another one. Let's say that I have I equals PRT. This is a classic just interest formula. So simple interest is interest equals the principal times the rate times the time. So if you were going to take out a small loan, the principal would be what you borrow, the rate would be the interest rate, and then T would be the time in years. So let's say for this one, we're not interested in what the interest is, we're interested in time. So my goal would be to get T equals some relationship between I, P, and R. Now, if you look at the right-hand side of this formula, we have P times R times T. And when we're trying to get this T alone, we need to undo the multiplication of P and R, okay? So we've got T, it's multiplied by P and R. We need to undo that multiplication between P and R and T. So what I would do to undo multiplication would be to divide. So I'm going to divide both sides of this equation by P times R. On the right, the P's cancel. So P divided by P is 1. The R's cancel. R divided by R is 1. That leaves me with a single T. And then the left-hand side, nothing's going to cancel. So I just get I divided by PR. So in this particular case, time is equal to the interest divided by the product of the principal and the rate. All right. Now, we could also have something that kind of combines these two methods where you have adding and subtracting and the multiplication and division, okay? So let's say that we have A equals P plus PRT. This is another formula involving interest. So if you took, for example, like a Math 143 class, you might deal with some finance stuff. You could see this formula. And for this particular problem, again, we want to solve for T. Now, the first thing you want to do is isolate the term that contains the variable that you want. We want T, so we need to isolate PRT first. So the issue is this standalone P. So what I'm going to do is I'm going to subtract P from both sides of the equation. So on the left, I'll end up with A minus P. On the right, the P's cancel, and I'm left with that other term, P times R times T. Okay? So now, again, I want to get T alone, and the issue now is that T is being multiplied by PR. So I need to undo the multiplication of PR and T. So just like the previous example, I would divide by PR on both sides. On the right, the P and the R cancel, leaving just a T. And then on the left, we get A minus P over P times R. And that's it. So T is equal to the difference of A and P divided by the product of P and R. So you can see we're following the same steps that we would follow when we're solving a regular equation, but things just aren't simplifying the way we're used to. You're just rearranging that formula, but you've got to rearrange it legally. So let's look at some other examples. Let's say that we have F equals mv squared, and we want to solve for m. So in order to get m by itself, we would need to undo the multiplication of m and v squared. Luckily, there's only two terms in this equation, the f that's by itself, and then the term that contains the m, so we don't have to add or subtract anything. We just have to undo this multiplication. I'm going to divide both sides of the equation, or the formula, by v squared. On the right, the v squareds cancel, and I'm left with m equals f over v squared. And that's it. All right, let's keep trying examples. Let's say that I have P equals 2L plus 2W. And for this one, I want to solve for L. Okay, so the first thing I want to do here, since I have multiple terms, I want to isolate the term that contains the L. So right here, I've got 2L plus 2W. I need to get rid of the 2W. And since 2W is being added, the way I undo addition would be subtraction. So I would subtract 2W from both sides. The 2W's cancel on the right, leaving P minus 2W equals 2L. Now, in order to get L alone, I need to undo what's happening to L. What's happening to L right now is it's being multiplied by 2. So I want to divide both sides by 2. And what that would do, the 2's right here cancel. So I would get L equals P minus 2W over 2. Now, there is kind of another way you could go about this. So from right here where we had P minus 2W equals 2L, the other way you could have solved this to simplify it a little bit better would be, instead of dividing both sides by 2, divide all terms by 2. It's the same thing, it's just going to simplify a little bit more. So the 2's here cancel, leaving L. The 2's here on the W cancel. So what we would end up getting is L equals P divided by 2 minus W. Truthfully, even though these look a little bit different, they are actually the same thing, okay? So it just all depends on how simplified you want your formula. I would absolutely accept either example. The first example that I did is usually a little bit easier for people to see, but L equals P minus 2, or P divided by 2 minus W is actually more simplified. All right, let's see. I'm going to mark out the examples on my paper as we do them. How about this one? Let's say that we have V equals 1/3 B times H, okay? So what we have here is something that contains a fraction. And at this point, you should have already learned how to eliminate fractions from an equation. So what we would do is we would multiply both sides by what's called the LCD. So the LCD in this case is just 3. If you had multiple fractions that you were dealing with, you would want to look at all of the denominators and find the largest value that all of the denominators divided into evenly. But if you just have one fraction, the denominator is the LCD. So what we do with the LCD is we multiply both sides of the equation by the LCD. So I would get 3 times v equals 3 times 1/3 times b times h. Well, on the left, we just get 3v. On the right, the 3 and the 1/3 actually cancel because 3 times 1/3 is just bh. Oh, I'm sorry. We're supposed to solve for b. I totally forgot to put that at the start. So we want to get rid of the fraction first. We did that. We get 3v equals bh. And then we're looking to simplify and solve for b. That means we want b by itself. Well, if you look here, b is being multiplied by h. We need to undo that. So we undo this by dividing both sides by h. On the right, the h's cancel. So we get that b is equal to 3v divided by h. And that's it. All right. Let's look at another one like this with a fraction just to get more practice. So a equals 1/2 times b times h. For this one, again, let's solve for b. Okay. So the first thing we want to do is we want to get rid of the fraction. So the LCD is just going to be 2 since there's only one fraction. So I multiply both sides by the LCD. So on the right, I get the 2 and the 1/2 cancel. On the left, I just get 2a. So I get 2a equals b times h. I'm looking to get b alone. The issue is that b is being multiplied by h. So I would divide both sides by h. On the right, the h's cancel, leaving just 1b. On the left, I get 2a divided by h. So b is equal to 2 times a all over h. And that's it. All right, let's see. I've got 1, 2, 3, 4, 5 more like this to practice. Then we'll do some more problems that are a tiny bit more in-depth. Okay, so let's say that we have, I want to find a good one. Let's say that we have a equals 1/2 times h times capital B plus lowercase b. This is actually the formula for the area of a trapezoid. And so this is supposed to be an uppercase B and a lowercase b. And if you're interested, we can look deeper into trapezoids, but basically you have 2 bases on a trapezoid. You have the larger base and the smaller base. That's all we have here, but we do have 2 different b's, capital B, lowercase b. So be mindful of that. And in this case, we're going to solve for the lowercase b. Okay, first thing I want to do is get rid of the fraction. So I'm going to multiply both sides by the LCD, which is 2. All right, on the right, the 2 and the 1/2, they cancel. 2 times 1/2 is just 1. So I get 1 times h times b plus b. And then on the left, I'm just left with 2a. Now, my goal is to get the little b by itself. So I can approach this a couple of ways. I could divide by h first and then do some subtracting, or I could distribute the h and then do subtracting and then do some dividing. Either way you look at this and approach this is fine. For me, I would go ahead and divide both sides by h. On the right, the h's cancel. So the left, I have 2a over h. On the right, I have big B plus little b. Now, remember, we're solving for the lowercase b, so the issue here is that added to the lowercase b is the capital B. So since the b's are being added, I want to subtract the big B since it's positive. I'm going to do that from both sides. On the right, the big b's cancel, so I'm left with little b, or lowercase b, equals 2a over h minus b. And that's it. There you have it. Okay. Now, if you had solved it the other way, where you distributed the b, or rather when you distributed the h, if you did that here, if you distributed the h, it would look, your final answer would look a little bit different, but it would still work. So let's look at it the other way. So we had 2a equals h times uppercase B plus lowercase b. And let's say your eyes saw it as needing to distribute the h. Well, you'd get uppercase B times h plus lowercase b times h. We would want to subtract BH, uppercase BH. So we would get 2a minus BH equals little bh. And then we have this multiplication of b and h that would have to be undone. So divide each term by h, or you can divide each side by h, whichever you're more comfortable with. H is canceled, and we get b equals 2a minus bh over h, or 2a over h minus b. Either answer is fine. Either approach is fine. Okay. So again, these get a little messy in our heads because we don't have numbers where things are simplifying and we're not combining like terms. So it's a little daunting to solve formulas for specific variables, but it's manageable. It definitely can be done. Okay, let's look at a couple more. So let's say we have S equals 2 pi r times r plus h, and we want to solve for h. Okay. Well, for me, the first thing that I want to do is I want to divide both sides by 2 pi r. Okay, h is in this set of parentheses and it's being multiplied by 2 pi r, so I want to isolate the r plus h. So 2 pi r, the 2, the pi, and the r cancel on the right. So that means on the left, I get s divided by 2 pi r. On the right, I get r plus h. Now I need to isolate the h. The only issue is this r that's being added. So at this point, I want to subtract r from both sides. So I would get s over 2 pi r minus r equals h. And then if you want to write it, you know, h equals, it would look like this. And that's all. Okay. So it gets easier with practice. It's a little weird at first. Again, we're hopeful that things simplify and cancel and collapse. They just don't do that here when you're working with formulas. Now, another thing that you will definitely have to do, especially when you get into graphing, is you're going to have to solve a linear equation in 2 variables for y. Okay, so let's say you have something like 12x minus 6y equals 18. Okay, so what we would want to do here is solve for y, and there is a use for this, and when you get into graphing, you'll see that use a little bit more, but it's good to practice it now so that when you have to actually apply it, it's something you already know how to do. So what I would want to do here is isolate the term that contains the y. So I've got this plus 12x minus 6y. I need to undo the plus 12x. So I'm going to start by subtracting 12x. 12x is on the left cancel, leaving me with negative 6y. And then on the right, you can write this as 18 minus 12x, or generally speaking, the format you're going to use when you get into graphing, you're going to put the x term first and then the constant. Either's fine, but generally you'll see it in the way I've written it down. And then you've got this negative 6 times y. If we can undo that multiplication, then we have solved effectively for y. So I'm going to divide by negative 6. And what I'm going to do for the sake of simplifying, instead of just dividing both sides by negative 6, I'm going to divide all terms by negative 6. It just simplifies your final answer a little better. So the negative 6's cancel on y, so I'm left with just one y. Negative 12 divided by negative 6 is positive 2x. And then positive 18 divided by negative 6 is negative 3. And that's it. All right. So another one, just to make sure we understand how that works. We have 5x plus 6y equals 18. We again want to solve for y, so I would subtract my 5x. I want to isolate the term that contains the y. 5x is on the left cancel. I'm left with positive 6y equals negative 5x plus 18. Divide by 6. You want to undo the multiplication of y and whatever its coefficient is. 6's cancel. I get y equals negative 5/6. x plus 3. And this format, y equals some number times x plus some number, is actually really important, and it has a purpose when you get into graphing. Now, let's say that we have 2/3 x minus 5/2 y equals 5. So again, like the previous two examples, let's say we want to solve for y. The issue here is you've got fractions that make things complicated. So what I would do right off the bat is get rid of the fractions. So looking at my denominators, I've got a 3 and I've got a 6. The smallest number that 3 and 6 go into evenly, whoops, I said 6. We've got denominators of 3 and 2, and the smallest number those denominators go into evenly is 6. That's the LCD. So what I would go ahead and do is I would multiply all three terms by the LCD. You do have to multiply everything, even if it doesn't look like a fraction, you still have to multiply it by the LCD. So on this first term, 2/3 x, 3 goes into 2 twice, leaving 2 times x, or 4x. For the next term, negative 5/2 y times 6, 2 goes into 6 3 times. I'm left with 3 times 5 times y, or negative 15y. And then finally, 6 times 5 is 30. At this point, you've eliminated the fractions. You solve it just like we did the other two examples. I would start by subtracting 4x. That's going to give me negative 15y equals negative 4x plus 30. Divide by the coefficient of y. Watch those signs. So we get y equals negative, well, positive actually, positive 4. Let me rewrite that. So we get negative 14x divided by negative 15. Those negatives cancel, so we get 4/15 x. And then positive 30 divided by negative 15 is minus 2. So it's a little scrunched in there, but there you have it. That is solving a linear equation in two variables for y. And this is something that will absolutely come up when you start looking at graphing. All right. So what I'll do next is I'll do a few examples where I give you a formula that you need to solve for a particular variable, and then we'll evaluate that formula. Okay. So let's say that we have I equals PRT. Okay. Let's solve for R. Now, in this case, we have I as interest. So if you were going to make a loan or take out a loan or invest some money, I is the interest that you earn. P is what you initially invest or what you borrow. R is your interest rate. So interest rates can be any value, but a lot of times when we use them, we have to use them in decimal format. So if you had a 6% interest rate, you would not plug in 6 here. You would plug in 0.06. So be mindful of that. And then T is time. So what we want to do is we want to go ahead and solve for R. So I've got this P times R times T. So the issue with R is it's being multiplied by PT. So I want to undo that multiplication of R and PT by dividing. And I'm going to do that on both sides. So the P's and the T's cancel on the right, leaving me just R. And then I have that R is equal to the interest divided by the principal times time. All right. So we solve for R. So then the question we're asked would be something like, find R if I is 225 and P is 5,000 and T is 1. Okay. So we would take this new formula, R equals I over PT. We would plug in what we have. And then as long as you show your work, I'm okay with you using a calculator. So effectively we get 225 divided by 5,000. So I get 0.045. Now remember, I said when you have this formula, R is an interest rate in decimal format. But for us, when we talk about interest rates, we generally want to see it as a percent. So to write this as a percent, we would move our decimal twice. So we would say R is 4.5%. And that's it. All right. So be prepared to take a formula, solve it for a specific value, and then evaluate it given information about all of the other variables in the formula. So let's look at another one. Let's say we have y equals mx plus b. We are told to solve for m, okay? So we practiced some of this where we had y's and x's. So this stuff right here, all right? The last three examples we did on this slide, we had linear equations in two variables. That's kind of what we're dealing with here. It's just in a little bit more abstract format. A lot of you might actually remember y equals mx plus b. That'll come up in a much later series of videos. But what we want to do is go ahead and solve for b. That means we want to, or not solve for b, solve for m. That means we want to get the term containing m by itself first, okay? So I want to get mx alone first. My issue is this plus b. The way I undo addition is subtraction. So I get y minus b equals mx. And then I need to get m alone. The issue is m is being multiplied by x. So I want to divide both sides by x. So m is equal to y minus b over x. Okay. Now the question that we could be asked would be to find m if y is -1 and x is 3. So let's do it. Let's say b, I forgot b, and b is 2. All right, so we get m equals y, which is -1, minus b, which is 2, all over x, which is 3. So -1 minus 2 in the numerator is -3. Denominator is still 3. So that simplifies, and it tells us that m equals -1. So again, we took a formula, we solved it for a specific variable, and then we evaluated it given a certain set of information. So in this case, we needed to find y given information about y, x, and b. All right, 2 more, and then we will wrap it up. Excuse me. So let's say we have f equals 9/5 times c plus 32. First thing we're going to do is solve for c. All right. Now, this is the formula to find Fahrenheit if you're given a temperature in Celsius. So what we're going to do is we're going to solve it. We're going to figure out what Celsius equals, and then we're going to use that to figure out some temperature. Okay. So the first thing I want to do is isolate the term that contains the c, or you can go ahead and get rid of the 5, like the denominator of 5. It doesn't really matter which one you do first. I would say in this case, let's see. Let's go ahead and get rid of the 5, and then we'll get the c by itself. So the LCD here is 5. So I'm going to multiply all of these terms by 5. All right. So I get 5f equals, well, when I look at 9/5 c times 5, the 5's cancel, leaving just 9c. And then 32 times 5, I get 160. Okay. So again, we could have just moved the 32 over immediately and then dealt with the fraction. But for this one, we just went ahead and dealt with the fraction. Now we need to get the 9c alone. So the problem is this plus 160. I'm going to subtract 160 from both sides. The 160s on the right cancel. On the left, I get 5f minus 160. On the right, I have just 9c. Now, finally, to get c alone, I need to undo the multiplication of 9 and c. So I would divide by 9. You can either divide just both sides by 9, or you could divide each term by 9. It's really kind of up to you. So we have c equals 5f minus 160 over 9, or we have 5f plus, whoops, that's minus 160 equals 9c rather. So I could divide each term by 9 instead, and I would get 5/9 f minus, and then 160 divided by 9 we get something nasty. So we would, let me see how it reduces. So we would just get 160 over 9 equals C. Either of these would be fine. Okay. Or I'm not going to show you another way to simplify it. It'll be too confusing. So we'll leave it like this. So either of these, I'm going to stick with this one that's over in the left bottom corner. So what we're asked to do now is to find C when F is 59. So I would take C equals 5 times 59 minus 160 all over 9. So we simplify a little bit. 5 times 59, we get 295 minus 160 over 9. So 295 minus 160 is 135 over 9, which is 15 degrees Celsius. All right, now to be completely and utterly clear, I could have taken the initial formula, F equals 9/5 C plus 32. I could have gone ahead and plugged in 59 and eventually solved for C. It wouldn't have been that big a deal. But you've got to do what the directions ask. So if the directions tell you to solve however they want you to, and then evaluate. All right, one more, and then we'll wrap up this video. Let's say we have V equals 1/3 pi r squared times h. This is the volume of a cone. And let's say our first order of business is to solve for h. Okay. So for me, I'll generally get rid of the denominators or the fractions first. So I'm going to I'm going to multiply both sides here by 3. So I get 3v equals, and then on the right, the 3 and the 1/3 cancel to just be 1. So I get 1 times pi r squared h. Now, we want to get the h alone, and the issue with h is it's being multiplied by pi r squared. So I want to divide both sides by pi r squared. The pi and the r squared cancel on the right, leaving me with h equals 3 times the volume divided by pi r squared. All right. Now the question could be find h when the volume is 75 pi and r is 5. Okay, so we want to find h when the volume is 75 pi. All right, so we get 3 times the volume, so 3 times 75 pi, divided by pi times r squared. R is 5 in this case. So we'll clean this up a little bit. Let's see, 3 times 75, we end up getting 225. In the denominator, we just get 25. Notice the pi's cancel. Do you see how there's a pi in the numerator and there's a pi in the denominator? So the pi's cancel. And then 5 squared is just 25. And then finally, we want to simplify, and we would get that h equals 225 divided by 25, or 9. So the height of a cone, where the volume is 75 pi and the radius is 5, the height would be 9. Okay. So this right here is a fairly quick overview of how to solve formulas for a specific variable. It's a little bit harder, in my opinion, than solving an equation because things don't simplify down the way we want them to. And we get a little frustrated because nothing is simplifying and they can get a little bit complicated. In a lot of cases, your final answers can look slightly different depending on how you approach the solving and how you simplify. So I did an example where there were kind of 2 ways to simplify it, and I showed you both ways. The 2 answers were the same, they just looked slightly different on the surface. Okay, so just be mindful of that. If anything comes up and say you get a different answer than someone else, but you feel like you did it right, let me know, let somebody know, because it could be that both answers are right. One's just simplified a little more than the other. All right, so again, that's solving formulas for a specific variable. If you need anything else, let me know.